Hi, and welcome to part one of lecture 4, generating randomness. I recommend if any of the stuff concerning probability is difficult for you, that you go back and view the review on probability. And if it's still unclear, of course, please send me an email and we can set up a time to talk about it. So this is one of the hearts of what we do, which is in our simulations, we need to generate random numbers. And we have a very specific definition of random number in simulations. So a random number, just beware of, this is not the same as just a random variable. Because when we talk about random number, we have the very specific definition that a random number is a random observation from a uniform 0-1 distribution. So definitely note this definition, okay? Because this is not what the colloquial definition of random number is, right? This is actually, a random number is a very specific, random number is a very specific random variable in the context of simulation. Okay? In other words, it's this uniform 0-1. So the challenge computation is, how do we tell a computer to sample from a uniform 0-1? First of all, a computer works deterministically, so what does that mean? A computer it doesn't have a thought process the way you or I do, or other humans do, or even the way an animal might. It just does exactly what it's told by the way in which it's programmed. And in particular, a lot of times, if a computer starts acting haphazardly, it typically means that it's broken. So instead of getting a random number generator, we will talk about the fact that we're doing a pseudo random number generator. Okay, well, what do we mean by that? So we'll often abbreviate this with PRNGs for pseudo random number generator. Pseudo means having a deceptive resemblance. And what they actually are typically deterministic algorithms that use math formula or pre-calculated tables to produce sequences of numbers that appear random. And we need to make that a little more precise. So what do we want in our pseudo-random number generator? A lot of times it helps to understand the goals of what it is we're trying to do. Well, we want it to be efficient, which means that it's computable quickly. It has to be deterministic. So this seems like the opposite of what we want. We're trying to make randoms, but we actually want it to be deterministic, which just means that we can control the randomness. And I'll put the randomness in quotes. We want to have a long cycle, which means that it doesn't repeat, it won't repeat for a long time. Finally, it needs to pass some statistical tests for uniformity and independence. And this is really this is how we obtain our randomness. Okay, so it won't be truly random, but it's going to have all the properties of the uniform random variable. And it will be independent. In other words, a random variable from point A to point, for time point 1, and then if we generate the same thing in time point 2, it will look like it's being independently generated. Okay, so just to reiterate, efficient means it produces many numbers in a short amount of time, so it's easy to compute. This deterministic, it means we can reproduce for a given start point. And this is going to be useful for our experimentations. Okay, this is how we control our randomness. And then it has this long cycle. So it should be long enough so that we don't repeat our sequence for a very long time at least. And then it has to look like a uniform 0-1 distribution. It has to be able to be statistically identical to a uniform 0-1 distribution. Okay, I'm going to stop here, and for part 2, we'll talk about sort of one of the most fundamental random number generators, pseudo-random number generators, called the linear congruential generator.